Hey everyone, welcome to our show. I am really excited today because I get to be a product manager. And in that role, I'm going to be asking some questions about the e-commerce store that I have and how I'm going to avoid all that latency because I got a big promo coming up. So joining me for this discussion is Madhu Krishnarao, Senior Technical Product Manager at VMware.
Hey everyone.
Tuan Nguyen, Senior Technical Product Manager at VMware. And hey, how are you? And Bhushan Pai, Senior Technical Product Manager at VMware.
Hey, good morning, everyone.
So what's the deal here? So you got all these changes for me in my store here, and to make sure that my latency gets better, but I'm a little confused. Can you take us through a little demo of sorts or something to show me what the heck's going on?
Sure, Alex. We could definitely do that. Here we have a typical e-commerce platform, right? So I know you wanted to sell a bunch of really fun stuff. What we have set up is the entire e-commerce platform, and we also have everything set up in the backend. Like Tuan and Bhushan have been working really hard to set everything up. We want to kind of take you through what happens within the application, within the platform itself, to see when we get more requests, to see what happens to the latency and how we counter that. So with that, is that a good thing that you want to see?
I'm a little skeptical. I mean, I grew up with these 3-tier architectures and they seem to work pretty well. So let's see it, I guess. I mean, I got a lot of barista sets to sell. I mean, I got so many barista sets to sell. I got bicycles that my boss is saying I got to sell with the barista sets. And if that checkout doesn't work, I'm going to have no wheels. I mean, literally.
Well, let's see if we can put you at ease here. All right, let's switch over to the product. Yep. So this is the e-commerce platform. It's a pretty standard platform. You have items to sell, pretty cool items, as you can see. Let's start actually kind of going through what a user would do. Just purchase, let's say, a vintage typewriter. Everyone loves kind of typing, but iPads and keyboards are not cool anymore. So this is fun.
That looks like the typewriter I learned to use when I was a kid.
Yep, we found just one for you. So let's add to the cart. And you know what? Maybe let's purchase a few more things. Let's see, a vintage camera perhaps. And you know what? At least I like this one. So let's buy 2 of these.
My sister's really artsy. She turned her studio apartment into a dark room. I don't know how she sees around the place, but she'll like this.
Oh, great. I guess 1 for you and 1 as a gift. So yeah, let's place the order. And so you see the order is complete. So this is a kind of functional e-commerce site. And I know you want to run a bunch of promotions. And you also mentioned that it's a 3-tier architecture, right? But so here, let me show you what exactly this is. Now, don't get surprised. This is almost like a 11-tier architecture. So there are, yeah. So all of these are microservices. You have different services, one obviously for the front end. And when we say backend, it actually comprises of a bunch of things, right? You have your product catalogs, you have your credit card service that needs to process your money, that's important. Then you have your currency service. Of course, we want to go international, a bunch of other ones. So
let me ask you a quick question.
Mm-hmm.
So back when I got started in this work, I would just add some more servers. Just add a server here, add a server there.
Yep.
I had to make the sales. Later, the operations team would come to me and say, you spent a fortune on new servers. What is going on? And I'd be like, yes. I got to make my sales.
But then you wouldn't know how many servers to add, what to do once the promotion ends, what do you do with those servers. And then just the fact of adding physical servers over, connecting everything up, it would, I don't know, how long would it take? Days, weeks? So what?
Oh yeah, I mean 3-month lead time, but
Yeah.
they didn't
Exactly.
care. They didn't care. They just said, well, they did care, but what I would, what I did, what I do? I'd order extra of everything. I would
Yeah.
I would like load up on that compute. I would load up on that storage. Man, I had boxes and boxes and boxes. It works. It worked for me.
Yeah, you would be surprised to see what we can do today.
Okay,
So
great.
yeah, and actually want to hand over to Tuan at this point to kind of take you over with what he has in plan.
Hey, thanks, Madhu. It's Alex. So what you want to do next? So the application now running, and you have the full flow of all the application running in a fully distributed in multiple location. I know for a fact. Can you explore what your requirement is? You have the distributed system running in multiple location, right? You told me you have the HQ in Barcelona, and the second HQ in Mumbai, and the third one in Paris, right? You want to lay out this application fully distributed and completely agile and elastic and flexibility for you to go and reduce all the capex and opex. Is it right?
Yeah, that makes sense. Yep.
Well, let's see. Yeah. So let's see how we make proposal for you. So we have this solution that been deployed in the dev environment. Now we bring it to the production. How we do it? It's very easy. We have the 3 SQ, which is mentioned to you, right, Alex? So now we have Tanzu Service Mesh, which allow you to have single panel class and with the local.
Oh, hold on a second. Hold on a second.
Yes. Is it that's what you're looking for?
Hold on a second.
Okay.
First you said Tanzu.
Yeah.
And then you said service mesh.
So yeah, service mesh is the service mesh from Istio, and we have the Envoy is the data plane. We run in every single Kubernetes cluster. Tanzu is the name of VMware come up with, right? Allow you to do Kubernetes in the day 0 to day 1, day 2 operations. What does it mean by that? Does it mean how you build the application, how you run the application, how you manage it, all life cycle.
Okay, so let me just ask one quick question then. So you said Istio and Envoy. I've done a little. I've been reading the news stack. Okay, yeah. And I've been reading about Istio, and right. So like, Istio's based on Envoy, right? And Envoy, So what? So let me understand what the difference is between the two, because I'm gonna have to explain this to my boss anyway, and he's gonna.
Oh yeah,
and I can't just say, hey, go read the news stack.
Correct. Yeah. So this is the application that Madhu just deployed. Envoy is the data plane and running in single cluster. And Istio is the control plane is running on top. And that's still in the single cluster. Now you have the requirement running distributed fully global in different locations. In this case, in Barcelona, Mumbai, and Paris. So we have Tanzu allow you to group them together. And not only that, we can help try with all the load balancer with my Bhushan, my colleagues, going to show you how it works in the next slide, right? So that together, we bring you the full life cycle. It's a completely agile. And that's a phenomenal thing, right? So in the real time, you can see what happened inside your every single cluster. You don't need to go to Mumbai, to Paris, to Barcelona to check what's going on in each cluster. It's just one single click. You can see the entire system from day 0 to day 1.
Okay. I can explain that.
Yeah.
Because it's all about explaining this stuff. Because if you can explain it to me well enough, if I do half as good a job, it might suffice. So let's keep going.
Yeah. Go ahead with Jimin, Madhu. Any comment on that, right? So your app now running in fully global scale with the ALB. We'll talk a little bit later with my colleague Bhushan, right? And then on top of that, now we fully distributed from virtual machine and container in multi-cloud, right? And fully auto sync from ALB to Tanzu. And then on top, we build a full life cycle here. We have the single panel class kind of, and we can group them together in logical construct like GNS. We talked a little bit earlier. In the demo, you see all of that. GNS is global namespace, allow you to group multiple Kubernetes namespace. And on top of that, we build some kind of ingress gateway to tie on a workload from virtual machine to container and connecting to multiple type of apps. It's kind of cool, right? We have fully secure on top of that. We can run MTLS and check all the users, permissions, database, everything, fully discovery. And we have built-in on the DNS system, on-cap system to allow you to do the whole life cycle. That's the whole demo gonna be about.
So there's two types of controllers then. There's the global controller and then there's the local controller.
Correct. So
why do you need a global one? Why do you need a local one?
So Kubernetes had the local controller is the Kubernetes API, right? Where we interact with. So Tanzu running inside the local, every single cluster, right? In here we have 3 HQ, 1 and 2 and 3. Every local controller acted their own, and they have the data plan running across. So, but to tie together, Kubernetes does not have the concept federation. That's how we came in. That's why Tanzu come in and help you to leverage. And ALB also scale the app along with the application and the load balancer. Does it make sense?
Yeah. It's getting there. It's getting there.
Okay. So that we didn't go to the demo. This is the high-level architecture. Let's go to the demo and we come back to your question. Okay. Thank you. Let's start the demo. So let's click on that. So this is the Tanzu service mesh. So you have explained how you want to serve your OPEX and CAPEX, right? Exactly what we have. A single panel class. Every cluster here, there's a Kubernetes cluster running where we have the local controller running and the Envoy is a data plan. And on top of that, we have the CNI plugin, which is Antrea in this case to do the CNI plugin, allow you to connect on the IP address. You need the IP address, right, to make it work across multiple clusters. We have that solution as well built in. And in here, we have a second cluster in Mumbai and the third one in Paris. And one single clicks that the GNS we can tie together and make a single panel class. So that is the full 56 services running. Not so much workload right now. We didn't generate a lot of traffic. We just bring it up to production.
So when the promotion is running, when I'm like selling my barista kits off the shelves, they're going fast. Do I have to be able to log in to each one of these clusters?
You don't have to. It's gonna self-running, and we're gonna define some SLO, the user experience with you, and based on that, we automatically detect any event happening. And we have, thanks to Madhu, and he has all the scripting on automation mechanism behind the scene, allow you to scale. You see how cool we're gonna do it in one single click. You don't need to go anywhere. We just stay in the GUI and do the best for you is to build the app and run the app. So the rest we're gonna take care of that as the infrastructure.
So you want us to just focus on building that awesome front end to sell as many finished typewriters as we can.
Yeah, that's coming in one cluster. We can see that. That's exactly the app that Madhu just showed to you, right? It's fully distributed. We have the load balancers, we have the ingress gateway, and traffic go to the front end and flow into different location in here. And you can see that it's completely all of the connections has been managed on one single click. And right now we have about 400 requests per second. The latency is good. The error rate is very low. So there's nothing wrong with that, right? Now, how you scale this app, how you run in real production with ton of traffic coming, right? That's the challenge. But before you go there, they see how it looks, right? How many requests coming from the front end, you do checkout like Madhu just did, right? And we can do the payment, the shipping, all kind of thing, right? And we can click on that. This is come from the local controller. And this is we at the global level. And the local controller in Barcelona report to you. And you click on all the SQ, you see the same thing as well. You don't need to go anywhere. That's a single panel class kind of to come up with. And that all the services running here. You can see that what's going on. So how many load generator, how many checkout services, and we can click go back, and then we can see that the whole thing happening in single click.
Okay, so here's what I've done. I've decided to like invite a bunch of my pals to to kind of check this out, and I think some of them actually might be like senior executives in the company. And so just be ready. There might be a question or two. And if you have a question, you're watching this, you can post it in the YouTube comments. So, we've got a worldwide audience here, and then you may get some questions, y'all, because this is a big deal for us. Oh, there is one. Look at that. Oh my gosh, my boss.
Thank
My boss is watching. Oh boy. So let me look at this. Libby Clark says, good morning. So when you say single pane of glass, does that mean it's cloud agnostic? You can manage all of your Kubernetes clusters across regions and clouds. What enables that? Libby, thank you. I was going to ask that question, I swear, but Libby, thank you very much.
So Madhu, why don't you jump in on this question? It's good for you too, right? Go ahead.
Yeah, definitely. No, it's actually a great question. It's something that if you're thinking about scale, that's number one thing that you would also ask, right? How do you manage all this, or where is all this information coming from? So as part of the VMware Tanzu portfolio, what we have is Tanzu Mission Control. And using that, you can, in fact, talk to any Kubernetes cluster on any different platform, whether it's on the cloud, on your local on-prem sites, doesn't really matter. So it does give you a single pane of glass. You will be able to connect to multiple clouds, Kubernetes clusters across different platforms. So yes, what we are showing here is that is Tanzu Service Mesh, where it kind of gives you the interface between all of these different clusters. So there's the management part, and then there's the control plane part is what we are showing here. So Great question. Thank you.
Yeah. So now, because we already onboard everything, Alex, so you have it running in different locations geographically, right? So now how we tie together in single pane of glass, not only do the connection together, you are not allowed to define the global policy. Like we do it here, we call it the SLO, which you focus the most is your experience, what you're going to see in your real application, not in the GUI in here, right? So how we do that? Basically, when you click on here, you can go and see the front end, how many services running, and you can go and define the SLO we're talking here. So the SLO is your experience. You're going to see here, this we have the hipster app, which is the online boutique that Madhu just didn't deploy. And here we define the rate. So this can adjust anything you need. And just single click, we go and deploy and apply this policy. And we see if any violation in here, you focus on, and the error rate, if we go beyond 2%, you're going to trigger some action. That's how Madhu coming and build the scripting and everything going to be fully automated, not only in the cluster, in the Kubernetes, in one single place, but the global and multiple locations. And then also the scale with the ALB, so load balancers, the whole site life cycle from day 1 and day 2, kind of triggering the full automation. That here we have the P90 150 millisecond and P99 400 millisecond. And you okay with that? That means you have 99% is below 400 millisecond. Only 1% is gonna violate that, gonna trigger some action. It's the auto scale in this case, right?
So tell me like how that would like be similar to something that I would have built on my platform, I don't know, before the service mesh and microservices started to come around. Like, what's that equivalent to, that SLO, in more of a 3-tier architecture? So
the SLO, that's the SLA in the real application that you see at your end, right? With your user gonna see it, not in the server. This in the end-to-end experience you're gonna see across multiple locations. Let's say that your app can run the front end running in Barcelona, the back end can run in Mumbai, and they have the latency between them. How you experience that? The customer doesn't care where the app running, but it does care how we're gonna see it. When you do e-commerce, it's very critical, the matter of millisecond. If you don't see this happen, you're gonna go somewhere else, you can buy something else and different website, right? That's so critical. The service latency is that point. Yeah, that's how we define it, 400 millisecond. It can even go below that. Let's see how it look in the real action, and go back to your question right after that, right? So this is the request. They will start having some question. I heard you need a lot of requests coming, right? And see how real in production. Am I correct? So let's have some traffic going through that, right, Alex? How much traffic? 1,000, 2,000 requests. See how it looks in real production, right?
Mm-hmm.
Let me refresh it. When you refresh, you see more traffic coming now through the system, right? Now we have like 600 requests per second. Now you're to ramp up to 1,000, even more if needed. And you see there's some latency happening, right? And let's go down a little bit, and you see that P90 and P99. Let's go a little bit down. You see that P9. You see that P99, we define 400 millisecond. the P90 in 150 milliseconds. There's some pipe here, right? And that's inside your cluster in Barcelona. But you want to see your app running in multiple locations, right? Not only in Barcelona. And look at the request coming in here. Only the latency in your cluster. Your app can run in multiple locations. That's how we see it.
So, so a quick question. How do you know what the latency is with, what is the best latency between services?
So that's how we have the Android running every single cluster. We have the local controller detect and report it to the global manager. That's why we need a global manager. So this is the local controller report in Barcelona, HQ1. Now I click performance in here, you see the full end-to-end latency with the entire application. That's how you see it running in multiple locations. That's the full end-to-end. So you have 80 services instant running and 800, 700 requests now coming. And you zoom in here, P99, you see that's going to flag because you already defined the SLO right before that. Now you see anything above that is trigger the red alert, right? Now, if you go back to the Kubernetes behind the scene, what happened? This triggers some action, right? Let's look at the Kubernetes cluster. And that's it. You're familiar with that. Madhu ran that for me and the kubectl control. And then they show the whole cluster running in Barcelona. And you see that all the front end has been scaling already upfront. Now, how the whole infrastructure is scaling. You don't want just the front end. You want the load balancer. You want the end-to-end experience for the customer. How you make it, right? So before I do that, I need to see it, what happened in the load balancer, and my colleague Bhushan gonna give you more detail. That's how we define it, Alex. So we get the Istio gateway. That's how we run in every single cluster. And every node, we have the Istio running with the AVAKO. This is our AOD. Running is the CRD, custom resource definition. Allow you to capture all the event. So Bhushan gonna walk you through a little bit more detail about that, right?
Well, look.
That's exactly what happened behind the scene.
There's another question. There's another question coming in, and it's coming from the person who, there's Colleen. She's a tough one. She wants to know how that experience is. She's always asking me, how's the experience going to be? How's the experience going to be? So how do we know where the latency is coming from? How do we know, where to turn?
It could be coming from cluster, right? So it could be coming from multiple places. That's why we need a global controller. Let Bhushan and Madhu jump in and respond to this question.
Yeah, so
sure.
At a global level, the traffic can go anywhere, but once it reaches a certain web on a certain site, your local controller is handling that. And at that place, you also have your Avi running, front-ending your applications as a load balancer. So Avi has a great dashboard where it can show you everything from where your client is coming in, from what type of browser is using. And there's a slew of a full package of analytics tied into that. For example, right now, as we are looking out here, we are just looking at the end-to-end timing, the latency part. As you see, as the traffic increases, your latency that your customers are experiencing is getting higher and higher. With your elastic and resilient application that you have, you also need an elastic and resilient load balancer or ingress controller to deliver that application to to your customers, so that the load balancer is not a bottleneck.
Yeah.
Can you go to the next?
Yeah, so that's how we see it here, right? We define 400 milliseconds. This is average 350, 348 milliseconds. You already hit this threshold, right? And the threshold has been hitting, so that's why we trigger some action. So before I hand it to Bhushan, one last thing, right? We not only do the load balancer, we also can offload the whole traffic to a different cloud as well. We have the concept called GNS that's uniquely in Tanzu. So it's allow you to group the concept in different cluster in one cluster. There's 2 cluster, 26 services, already grouped it. And in here you have the 3 tiers, the online boutique apps, right? Where Madhu just deploy. And if I go down a little bit, so we can tie to second cloud. So we can upload the whole thing in Barcelona to Mumbai in one single click. And how we do the magic thing is, Bhushan gonna take you to the next step. I'm done with the SRE job. Is it good enough? Good enough, Alex? You good?
Yeah, I think so. I know my team members are watching this, and they're going to have some questions about about this aspect of it, because they're always getting to me about that experience. So let's move on, and I think there'll be some questions coming in.
Okay. Correct. So go ahead, Bhushan.
Yeah. So as you see, Avi is we are using Avi out here, or it's also called as NSX Advanced Load Balancer, and it's providing ingress automated ingress services for all the clusters. The way it is automated is like you don't have to put in your create an IP address, publish a DNS manually. Everything is taken care by the Avi itself. So it automatically syncs the services and ingresses on the Kubernetes side, creates corresponding virtual services as you see out here, and monitors their health. As you see, everything is green and healthy at 100%. If you dig down into the front end of our application, you see that it's constantly getting some traffic right now from our users, and it's around 500 or so requests per second. And now, Tuan, if you can hover over the name. Yep. So you see that it's running on 2 service engines, running active. Those are the actual load balancing entities that Avi has, which is managing this application load balancing traffic. But as the traffic increases, so Tuan, if you can go back to the graph. Let's see. Let's wait for a few seconds, and yeah, as more and more users come in, as the request numbers keep on increasing, we have configured a threshold in our load balancing configuration, saying that if it goes above this, let's give the user a better experience and scale out, so that we don't be the bottleneck. So as this traffic increases, you can see that the service will automatically say that it's scaling out. So Tuan, if you can click on the name of the application again. So the UI shows you all of this happening in real time. You see it says currently the application is scaling out, and in just a few seconds it will add another service engine. Can you click on that? Yeah. So it just added another service engine. Now we are running active on 3 service engines, and this will keep on going until we hit a certain number of service engines that we have configured. So it won't like explode into hundreds of service engines. You can configure that too. But yeah, all of this is customizable, and you have more resources, load balancing resources now. And as you see down under the graph, you have events showing that the virtual service actually scaled out. So Alex, your application is completely safe, both from your application scaling point of view as well as the load balancing and networking point of view.
Okay, great. We do have a question from PV Rangaswamy. And PV asks, the AVI load balancer is layer 3, 4? I mean, he actually meant 4 or 7.
Yeah, so it does both layer 4 and layer 7. It syncs both load balancer type services from Kubernetes as well as ingress services from Kubernetes. So, and it does not actually require an external load balancer. The service engines which we are talking about does both layer 4 and layer 7 in the same go.
Excellent. So when we're looking at this, why these new load balancers? Is it because they can auto scale? Like, why not just use our own traditional load balancer? I mean, load balancer's been around for years. What kind of innovation are we seeing really here that kind of make a difference for us?
Just like our regular legacy servers that you were talking about a while ago, which we moved to microservices, these microservice environments require a lot of go into a lot of churn. So there needs to be a adaptive load balancer in front of them. So that's what Avi does. If you go for a legacy load balancer, you have to pre-provision or provision extra resources so that you take care of the extra traffic you might get at some point of time, and then you have to decommission it again. It's operationalizing becomes really difficult. But with the software load balancer that like Avi, you get elastic scale whenever required as your traffic changes with your application.
Okay, great.
Not only does it scale up when the load increases, it actually also scales down as the load decreases. So that way, you as an ops manager, you're actually just sitting back and then seeing it do all the heavy lifting.
All right. All right. There was a question I had about kind of when I was looking at the services you were showing before, and some of them had, different requests per second. There was, when you're looking at the load balancer, there was a pretty high request per second. And when you get into the checkout, it was much different. What's the difference there? Is that just the flow of data coming through the service and how it's getting distributed?
Yes, precisely. So the entry into the application is always through the front end load balancer. That's advanced LB here. So this has latency information about traffic coming in. But once it hits the LB and then it passes the request to the services, now this service has a bunch of different microservices within it. Now, these microservices could have been deployed in the same cluster, in the same location, multiple different places, depending upon how we deployed it, right? And that's the latency that you saw before.
Okay.
So there's the traffic coming in, and then once it hits the application, within the application, there is communication that happens between different services. And going back to the question, I think Colleen had asked before, those latencies as well helps you look at your application. So let's say if you look at a big latency with your checkout service, so you kind of know, you can go talk to that team that kind of developed that application or microservice and say that, hey, you know what, can you kind of look at this again and then make it a bit faster, so you know exactly who to go talk to.
Now we scale up already. Alex, you want to see how we scale down back, right?
And yes, I want to see how, for sure.
Right, let's do it. Then Madhu, can you walk us through the next step?
There is a question too. Do you want to hear the question? Because it might relate to this a little bit.
Okay.
Absolutely.
So Bruce Gain asks, and Bruce is one of our best product managers. He's a good one. What are the limitations of load balancing for distributed service mesh connections?
Okay, maybe Bhushan, I can take a little bit and then you can continue for this. So service mesh and load balancing is actually two different layers, you could say, because what service mesh is doing is just presenting your different clusters across different geographic locations as one component, and the advanced load balancer is now presenting this to your consumers. The disadvantage, specifically when there is service mesh in the backend, is actually nothing. It's behaving as one really big or one happy application at the backend.
Yes, so here's the thing, right? Let me jump in a little bit. So the service mesh is doing east-west traffic, right? So more or less Istio and Android together, right? So VMware we come up with, and then we add all of services on top to do all the lifecycle management, right? The load balancers, we can do north-south traffic, like Bhushan and Nguyen does. If we can do north-south or east-west, and how? Go ahead. Yeah.
Does the north-south traffic, manage the north-south traffic, and it runs external to your cluster, so it's not limited by the resources that you have in your cluster, and it can scale out elastically. That's how it manages the the bunch of the most of the traffic that your application gets from the north-south side.
Yeah. But look at it at the global level, like you have in services run in different locations, like you see, right? Geographically. So we can tie directly with the global controller, with the traditional load balancer, traditional service mesh, only tied to the local controller. And we can look at the local and also at the global level.
The Madhu service mesh also has an integration with the AVI controller for global services. So AVI has a GSLB offering using which it can manage the services globally, and TSM automatically creates the global service for your applications running across multiple geographic regions on AVI. So AVI does both the global load balancing for the north-south as well as the local load balancing.
So the cool thing is to reduce your OPEX, right? Even your CAPEX as well, Alex, at the global level. When you have a single pane of glass in geographic in one single place, in the global controller, allow you to single click, you push the policy in apply in Barcelona, in Mumbai, in Paris, in all the locations you have in one single click. And what happened in one single local controller, you see at the global level as well. And that's the cool thing uniquely we can offer.
Okay, excellent. All right. So what else do you have to show us? And I know that there's a lot of people who are really eager to see the rest of this.
Yeah, let's scale back, like Madhu, when you walk us through that. Okay.
Yeah. So now that we kind of saw how things behave when you scale up, right? It's the same thing when your traffic, let's say your promotion now ended, everyone's happy, you actually sold a lot of your barista kits. When you scale down, you still have to do some work in a traditional environment. This is where you would decommission certain servers, bring down some load balancers. But in this setup, this all happens automatically. Now, scaling down the app on a Kubernetes cluster is again easy. It can be automated. When that happens, the latency, or sorry, the number of connections coming in goes down. So the AVLB can scale down automatically. And here you see that the service mesh is detecting that there is the number of requests are going down. And yeah, we can see a lot more graphs. So this is all like live traffic. As and when things happening, you can start seeing it in the dashboard here.
Okay. So this shows how then, so I was going to ask a question about different times of the day, right? So, and so we see that people people get off work and they like to buy bicycles. I don't know why. Maybe they think they should be exercising, but how do we kind of balance that in terms of like, so we're not just doing it the old way, because I would get so much grief for like just saying just by overloading everything. And then when all the loads were down, it was like all that compute and was just it was still out there. So how am I going to be able to like scale things down when the peak is lower? When the demand is lower?
So it auto scale, right? The Madhu just show it to you, right? So it's a matter of you want to walk through this thing, we can go and directly respond to question this slide, Madhu. Yeah. I think we
right. So I was so what you're showing me was it could be any different time of the day.
Right? Oh yes, so it's a matter of day and month, even weeks, right? And whatever thing, right? You need to go through all the pans on when the things happen. Like you see, completely auto scale, right? You want to see there's something like 1,000 requests coming, and we got a ticket, we got latency happening, and then go to the support. Every guy gonna go and work together. Here is a matter of minutes, right? We just show in the demo here. You don't need to go on all the thing, everything here, right? So that's how this should work. And that's exactly what should be doing, right? So we have the very good user experience in SLO. You just defined it, right? And the log, the telemetry is self-healing, self-recover. So go scale up and scale down in a matter of minutes, even less than an hour. You saw the whole life cycle from day 0, day 1, and day 2.
So I bet then you could do something like collect all the data from your, where the greatest demand is and start to pinpoint it a bit. I know that's outside of our discussion here, but seems like there's a lot of data here.
Correct. Yeah. So Bhushan, you there? Okay.
Yeah. So like I said, with the data to debug anything that's going wrong, we also have great analytics to manage that, and elastically scalable load bands in front of that to manage the traffic in real time.
Yeah. This is on the real time we see here, Alex. So Madhu built all of all scripting behind the scene. We implemented an in Tanzu, which is blockable all the services. The load balancer today, you can add more services. You can put in the SIM, all kind of thing you can have on top of that. We fully integrate with all kind of solution on top. We provide the extensible and agile solution for the market, right? That's the thing, cool thing about Tanzu service mesh and all the solutions we see today. Yeah.
What about the network underneath? Just as a last question, how am I be able to kind of, keep the network managed? So this all is going to be able to run effectively.
Yeah, Madhu, you want to take this question for the network you built for us? Yeah, go ahead.
Yeah, sure. So this all depends on where your Kubernetes cluster. End of the day, the app is running on a Kubernetes cluster. Now, in my case, I just run this on-prem. But you could decide to do it in the public cloud, on-prem, different places, or however you want to do it. You could just build your own cluster. You could just get off-the-shelf solutions. Now, all of these clusters are actually running on a physical hardware. Managing that hardware is pretty straightforward, as in it's a well-known thing. People have been doing it. People love doing it. So that hardware, we are not actually changing. We are not trying to modify anything, or we are also not trying to configure new things within that physical layer, as and when we get more traffic, or as and when you want to see changes. So the physical infrastructure stays the same. Your cluster gets deployed, your apps just scale up and down, and your load balancing can handle the traffic, incoming traffic.
In the modern network, modern app, we call it, so it all is containerized. So the network is a CNI at the layer 2 level. So we have Andrea, which is open source with OBS, Open vSwitch based. And we can you can bring any kind of CNI. We support all of that. And advanced load balancer running on top, right? And thanks to service mesh running at the layer 7. And service mesh also running layer 7. It's tied together from the full end-to-end from layer 2 on the way to layer 7. And at the global scale, right? Not only single cluster, but multiple clusters together. So that.
Well, wonderful. I want to thank you for this explanation. I got to go talk to my boss about this. She's telling me that this looks pretty good. So we'll be back in touch, but I think we're gonna sell a lot of those barista kits. You know, I feel kind of lucky because we were the last container ship to get out before that Evergreen, got stuck in the Suez. So thanks for your time.
Yeah, everything you saw today is live demo in real time, and you can single pane of glass and single click, and you see the whole life cycle from day 0, day 1, day 2 operation. I want you to emphasize how easy, how cool is it. We have a solution end to end for you guys. Thank you.
Great. Well, I just want to thank all of you for joining us and helping this out with us. Madhu, Tuan, Bhushan, thank you so much for your time.
Thank you so much for having us.
Thanks a lot.